Thanks for inviting me to do a bit of presentation during this session. And mine is just to look at issues around high school, how we can integrate STEM education with real-world context to enhance readiness for tertiary studies. Well, Yancy did indicate that STEM education is a broad concept. So even here, I just sort of scraped a few things because I knew that I don't have all the time to present. Right, to start, the background to the invitation, among other things, stated that preparing today's learners with strong STEM foundations is key to building a future-ready society capable of thriving in the increasingly digital and interconnected world. Well, the key question that I'm supposed to look into is how can STEM be taught in high school settings to enable readiness for tertiary studies and facilitate swift mobilization to develop colleges? Well, it's quite a difficult question to answer, but I will just sort of try to quickly say a few ideas that I have for how this could be done. Well, this presentation will provide a brief but somehow comprehensive view of how high school STEM education can be reorganized to better prepare students for the challenges of tertiary studies, emphasizing interdisciplinary and contextual learning. While the importance of STEM education in today's world is noted from the opening statement, the presentation will look into the role of real-life teaching contexts and integration of subjects in the STEM, or integration of the STEM subjects. At the same time, an attempt will be made to make some suggestions for assisting learners with the transition from high school to tertiary studies. And lastly, the presentation will make recommendations for effective real-life teaching and ensuring that learners are ready for tertiary education. Let me start by looking at teaching using real-life contexts. What it means for me, I'll try and simplify it to the best I can. Teaching using real-life contexts simply refers to use of real-life issues to facilitate learning of new knowledge. This is a form of teaching that facilitates the connection of classroom education to practical and real life situations. What are the key features of such teaching? That is the real life teaching approach. Well, one of the key characteristics of this type of approach is that lessons are set up such that they address real world challenges people may face. Well, there are so many challenges that people face in the real life. This type of teaching involves learners in hands-on activities such as projects, experiments, or community services. The key benefit of this type of teaching is that it encourages analytical skills and problem-solving thinking, that is critical thinking. It promotes working collaboratively and hence encourages learning from each other, peer learning. Excuse me. It integrates multiple subjects to show real-world connections. And lastly, it is learner-centered. So learner interests and experiences are taken into consideration to prepare for teaching. All right, the roles that come from this type of teaching are, if learners have been taken through real-life experiences, they tend to become lifelong learners. And this actually then prepares them for learning beyond school. That is, prepares high school learners for tertiary education. The use of projects and experiments generally nurture problem-solving skills and make learners see the relevance of learning, and it actually engages them in real activities because they have to do the experiments. This enhances understanding of knowledge that is learned, which is very much promoted in documents that are produced by the department, amongst others. And it also ensures that whatever is learned gets retained. So that means it also enhances retention of knowledge that has been learned. Some challenges with this type of teaching. Well, the big challenge with this type of teaching is that it requires knowledge of multiple STEM disciplines, which I know that myself as a teacher lack, if I may so make a disclaimer. For instance, real-life-based teaching involves knowledge that may come from different subjects. While engaging learners in some of the activities or projects, you'll find that there will be outcomes that require knowledge of chemistry, knowledge of geography, knowledge of mathematics, physics, and other sciences. Well, I thought I should first sort of like share a few examples of real-life context that I have used in teaching the subject that I've taught. The first thing that I would suggest is, once a context has been decided upon, for instance, if you say, I'm going to use the context of cooking and baking as a real-life context, you need to do brainstorming. What exactly is it that you'll be doing? How you will do that? And why you are doing all that? For instance, from cooking and baking, you may want to know chemical reactions that take place and explore issues of fermentation. You may want to get data in terms of pH values of the ingredients that are used. You may want to get data around temperatures that are required, recipe, and so on. If you're looking at a financial and shopping context, this one may look into the nature of conservation and the costs for conserving nature. It may look at exchange rates from a mathematical point of view. And if you do sports and science as your context, real life context, you may look into issues of cost, trends, and so on and so on. And construction and manufacturing will also look into materials used, a proportion of the materials used in that event. And you find that that cuts across different subjects. I have decided to sort of take one scenario where, for instance, the real life context that I've decided to use is air pollution. And from that, I want to sort of share with you probable integrations that may emerge from doing hands-on activities around pollution. Around mathematics, you'll find that exploring pollution, you have to collect data. And statistics comes in because that data needs to be analyzed. And also you may want to find trends in terms of pollution, and stats comes in handy. Calculus may also come in handy when you want to model rates of change. For instance, in terms of pollutant dispersion. Algebra will also come in handy if you have to do modeling, setting up equations that show relationships between the variables that you've identified. Around physics, fluid dynamics may come in, understanding how M moves and the dispersion of pollutants. Optics comes in, where you investigate light interactions, looking at issues of diffraction and refraction. Issues of thermodynamics also come in, where you're looking at the energy changes due to the pollution sources. Around chemistry, you may want to know about the composition of the pollutants, whether you've got carbon dioxide, sulfur dioxide, you've got dust, and so on and so on. You may also be interested in chemical reactions that lead to formation of the pollutants. E.g., for instance, generally one pollutant is the ozone, how ozone is formed. Then you may look in issues of acids that are formed and that result in issues like acid rain, which also looks into knowledge of chemistry. Around environmental sciences, you have to look at the ecological systems, how the pollution affects the ecosystems, how does it affect public health, and subsequently, you may want to look into issues of sustainability. How can we sort of do intervention and reduce pollution? From the side of geography, you may also want to monitor air quality changes, and you may also want to examine effects on weather and the effects on climate change. There's a lot, but I'm just sort of browsing a few things that are possible from using air pollution as the real life context. You can see from the above example that automatically, by just focusing on air pollution, there is cross-curricular integration, which means we need a situation where we actually provide situations where people can work across curriculum. But we can use activities as context for others. For example, I've just chosen one. If I'm a maths teacher and I've got issues around ratio, rate, and proportion, mine would be initially to look at how does ratio and rate and proportion permeates around topics that are done within mathematics. Where does it feature in when I do functions, looking at issues of gradient? Where does it feature in when I'm dealing with calculus? Of course, again, rate of change, which is another form, it might be now rate of change pertaining other contexts, also comes in. If I'm looking at issues of finance, I could look into areas around interest rates, exchange rates, and so on. If looking at trig deals with ratios, because whenever we speak about the sine, the tangent, and the cosine, all those are ratios. And around statistics, sometimes you've got to compare things and look at relative frequency. And also looking at chance does involve ratio, rate, and proportion. So, which means when I'm teaching this, I should allow integration of all the various topics around this concept of ratio, rate, and proportion. Right. If now I'm looking at ratio, rate, and proportion across other subjects, other STEM subjects, you would find that, for instance, around physical sciences, when you do mechanics, velocity, acceleration, power, all those are rates. Particular nature of matter, when you look around Boyle's law, you've got proportion that is involved. Around chemistry, chemical reactions, how chemical compounds, molecules, atoms react, there is a ratio that is involved. For instance, if hydrogen is reacting with oxygen to form water, the ratio will always be 2 to 1. Issues of ETG, you'll find that you have to do design, and in designing scale. Scale compares what is in the picture or what is in the drawing to what is in the reality. If you do graphic, but again around ETG, when you manufacture objects, there are issues of proportion that will pitch up. Around geography, the same thing. When you look at population, you actually would look at population density and population demographics, population growth rates, population death rates, and so on and so on. And around climate, you may look at what happens as air rises, how does temperature change, issues of slope around geomorphology, and so on and so on. Then let me just sort of wind up quite quickly without getting deeper into all the other things. I want to make a few recommendations for how this type of teaching could be supported. Number one, the presentation recommends that teaching of STEM subjects should focus on teaching for proficiency. In fact, in every subject, especially mathematics, proficiency is the key, because proficiency looks into, do people understand what they are doing? Do they know procedures for doing what? Can they reason out things and think critically about what they are doing? So we recommend that people find situations that make learners think deeply and critically about the core subjects that they are doing. They think deeply about the math they are doing, and they think deeply about the science that they learn. We must also ensure that learners can identify links between various STEM subjects. They don't see them as self-standing, but they know that these subjects have overlaps. We also need to extend learners beyond what is prescribed in the curriculum. That's now preparing them for education in the tertiary level. Of course, we've got to cultivate in them appropriate mindset. That is, we need to actually provide a bit of mentoring so that we bridge the gap between high school and tertiary education. Around teachers, a lot has been said regarding teachers. Most teachers are specialists. Either they specialize in maths or specialize in physics in our. So it would be recommended that committees that are interdisciplinary should be established. This may help teachers learn from each other. Connecting teachers with people that are in STEM careers, engineers and other people, people in agriculture, that would help them understand how their subjects actually contribute towards work that is done within those careers. Probably in closing, I would say the establishment of organizations like NSTF that can provide a platform for interaction amongst educators would also be recommended. Well, the presenters that have come before me did point out at some of the constraints like finance. So I think they've actually made suggestions that when we plan, we must also consider the constraints that we have within our schools. I saw that even Dr. Mhlani did suggest that because there is problem with getting internship for TVET colleges, for students in TVET colleges, suggesting that we might need to have virtual internships. Trouble even with trying to bring in a real life based type of teaching. Simulators or simulations could be used. Let me pause there and say thank you for listening to me.